Hello everyone, and today I'm going to talk about velocity and acceleration in differential equation. So from the last video we talked about a basic differential equation like this: dy by dx equals to function of x. There is no y's there, and we know that to solve for to solve for the general solution, we have y is equal to the integral of the function of x dx. And well, in this video we're extending that concept second derivative, so we have d squared y by dx squared is equals to a function of x. Well, again, we need to find the solution to this, so we need to find y equals, and so let me guide you step by step how to do that. So first, by looking at this, to reduce the derivative we need to integrate it, so we have dy by dx is equal to the integral of f of x dx. Okay, well, the integral of this is just big F of x plus a constant of integration c1. This is our dy by dx. Well, and to find y we need to integrate this again, so if y is equals to the integral of f of x plus c1 dx. Well, this is just another big F of x plus c1 times x plus a constant of integration c2. This is our y. So this is the solution to this differential equation, this basic differential equation. And well, we can make this and help with acceleration, so how to find the position function in acceleration. And we know that the velocity function is just the change of the position respect to time, and acceleration is just the change of velocity respect to time, or you can write it as the change, the second derivative of position over time. Okay, well, if you take a look at this, d squared x by dt squared is equals to a of t. Well, this is the same form as this one, but as t is the independent variable and x is the dependent variable, so we have the same technique, so we just integrate it. So we have dx by dt is the integral of a of t dt. Well, here's the thing, let's say in this case a of t is a constant, so let's say a of t is equal to k. Well, dx by dt, or we can say the velocity function. Remember, the velocity is just the change of position respect to time. It's just the integral of a of t is k times dt. Okay, well, integral of a constant is just k times the independent variable t plus c1. Well, this is just the general solution, v of t. Well, we want the particular solution, so we let v0 is equals to v initial And why 0? Why we pick time equals to 0? Because when time equals to 0, we can cancel out the k, which left us with c1 equals to our v of t. Well, when v of 0 equals to v initial, well, c1 equals to v initial, our constant. So we have v0 is equals to k times 0 plus c1. Okay? And v of 0 is equals to v initial, so we have v initial equals to 0 plus c1. And v initial equals to our c1. Okay, we can put it in our equation here. So we have dx by dt is equals to k times t, okay, plus by c1, which is just our v initial. Okay, good. And again, this is our velocity function, v of t. We want the position function, x of t. So we need to integrate this again. So to find x of t, or you can say integral of dx by dt is x of t equals to k integral of kt plus v initial dt. Well, this just simply becomes k times the integral t dt plus integral of v initial dt. X of t is equals to k times the integral of t dt. Well, integral of the independent variable is just t squared over 2 plus by integral of v initial dt. V initial is just a constant, so we have the constant itself times the independent variable t plus a constant of integration c2. Well, again, this is the general solution. We want the particular solution. So we have x of 0 is equals to x initial, so the initial position, and that means we have x of 0 is equals to k times 0 over 2 plus v initial times 0, okay, plus by c2. So x of 0 is just x initial, so x initial equals to 0 plus c2. Well, then c2 is equals to our x initial. Okay, nice. So we have in here x of t is equals to k, okay, over 2 t squared plus by our v initial times t plus by c2. c2 we already found that it's our initial position, so we have, oh sorry about that, x initial. It's our x initial. Wow. X initial. Okay, that's nice. That's our solution here. X of t equals to k over 2 t squared plus v sub 0 times t plus x initial. Okay, let's move on to the examples. So from before we have the k is constant, so let's now see if k, I mean the acceleration is not constant. So let's see if a of t equals to 3t plus 1. So we have d squared x, the second derivative or acceleration, is equals to a of t, Well, a of t is just 3t plus 1. This is our acceleration. Well, to find a velocity, again, we have to integrate it. So dx by dt is just the integral of 3t plus 1 dt. Well, integral of this is just 1 over 2 times, not 3, 1 over 2. 3t squared, okay? And then plus by t, plus by a constant of integration. And, well, again, we want a particle solution, so we need v of 0 is equals to v initial. Well, dx by dt is our v of t. V of 0 again is a half times 0 plus c1. V of 0 is v initial. V initial equals to c1. Okay, we can input it into the equation. We have dx by dt, or v of t, is equals to our this one, a half 3 over 2 t squared plus t plus v initial. Okay, well, our v initial here is just 2, so we have v of t is equals to 3 over 2 t squared plus t plus v initial 2. Okay, great. That's our velocity function. And now we need to get the position function. The position function is just the, again, integral of the velocity function. So x of t is just integral 3 over 2 t squared plus t plus 2 plus dt. Okay, now we need to integrate this, so we have x of t is equals to, well, integral of t squared 3 over 2 times 1 over 3 t cubed plus by t squared by 2 plus by 2t plus by the constant of integration. Well, we can cancel these. A half t cubed plus t squared by 2 plus 2t plus c2. This is our x of t. Oh, sorry. X of t. Well, again, we need c2 to be our x initial, so we have x of 0 equals to x initial. To find the particle solution, so x of t, x of 0 is just a half times 0 plus 0 over 2 plus 2 times 0 plus c2. Well, this all becomes 0. We have c2 equals to x of 0, which is just x initial. Okay, then we have the general solution, the particular solution. X of t is equals to the a half t cubed plus t squared over 2 plus 2t plus c2. We found the x initial, so it's 4. That's our particular solution. Okay, next we have a of t equals to the square root of 2t plus 1. Well, v initial equals to 6 and x initial equals to 2. So, again, same idea. We have the square root of x over dt squared is equal to our a of t. D squared x over dt squared is equals to a of t, which is the square root of 2t plus 1. Well, this is just as our acceleration, so we have to find the velocity, or dx by dt. We integrate this 2t plus 1 dt. Remember, we can solve this by using u substitution. So let u equals to 2t plus 1, du equals to 2 dt, or dt is just our 1 over 2 du. And well, we can substitute this back here. We have integral of square root of u. Dt is our half du, so a half du. So we have a half integral of square root of u is just 2 over 3 u to the 3 over 2. Cancel this. We have 1 over 3 2t plus 1 3 over 2. Okay. Don't forget plus by constant of integration. Okay, nice. And this is our v of t. Again, we need to have a particular solution, so we have v of 0 equals to v initial. So we find v of 0 is equals to 1 over 3 times 2t plus 0. Wait, 2t. This is 1, yeah? Not t, so we have 2 times 0 plus 1. 3 over 2 plus c1. Well, 1 over 3, this becomes 0. And we have 1 to the power of 3 over 2 plus c1. This becomes 1. And this of v of 0. Well, our c1 becomes v of 0 is just v initial minus by 1 over 3. Well, we know that v initial is just 6, so we have c1 equals to 6 minus 1 over 3. We have 6 times 3, 18 minus 1, 17 over 3. This is our c1. So our v of t is 1 over 3 2t plus 1 to the power of 3 halves plus by c1. c1, we know that it's 17 by 3. That's our constant. Wait, let me check if this is correct. Yep, 6 minus 1 over 3. Okay. Well, this is our v of t, not just our x of t, which is the position. So we have x of t is the integral of v of t dt. So x of t is just 1 over 3 2t plus 1 to the power of 3 halves plus 17 by 3 dt. We integrate this. Okay. Well, okay, so how do we integrate? So we have 1 over 3 integral of 2t plus 1. Again, we use u substitution, plus 1 3 over 2 plus by our 17 dt. Okay, 1 over 3. Well, we use u, so yeah, u at integral 2t plus 1 3 halves dt plus 17 integral 17 dt. let w equals to 2t plus 1 and dw equals to 2 dt, then our dt is equal to dw over 2. Well, then this becomes, this is 1 over 3. This becomes 1 over 3 times a halves integral w equals to this one, so we have 2t plus 1, 3 over 2. We already make this as w, so we have w to 3 over 2 dt, dw. Well, we have 1 over 6 integral of w to the 3 over 2. It's just 5 over 2, so we have 2 over 5 times 2 over 5. W to the 5 over 2. And this becomes 3. We'll have 1 over 15 w to the 5 over 2, which is just 1 over 15 2t plus 1 to the 5 over 2. Well, we have our x of t is just 1 over 15 2t (1 over 15 2t plus 1 5 over 12). Okay, and we have plus by, okay, the integral of 17 by 3 here, 17 by 3, we would have 17 by 3 t plus by c2. Okay, again, we need to have x of 0 equals to x initial, so x of 0 equals to 1 over 15 1 to the power of 512. I mean, sorry about that, it's not 12, it's 2. We have 5 over 2 plus 17 by 3t plus c2. Well, this is 0 right here, 0. Well, our x of 0 is just 1 over 15, okay, plus 0 plus c2. Well, x initial equals to 1 over 15 plus c2, then x of 0 minus 1 over 15 is our c2. Sorry about that, of c2. So we know that x initial is just our 2, right? So we have 2 or 1 over 15 minus 1 over 15 is equals to c2. Then our c2 must be 14 over 15. Okay? C2, yeah, C2 is 14. Wait, sorry, it's not 14 over 15. It's 30. So 30 minus 1, 29 over 15 is our C2. And then our particle solution, x of t, is just 1 over 15 2t plus 1 5 over 2 plus 17 over 3t plus c2. C2 is just 29 over 15. Okay, great. Okay, next, a of t equals to sine of 2t, v initial equals to 2, x initial to 8. Okay, again, same idea, we have d squared x by dt squared is equals to our a of t. Well, this is our, to find the v of t, we integrate our a of t, which is the sine of 2t dt. Well, the integral of sine of 2t dt is just a negative 1 over 2 cosine of 2t plus a constant of integration. That's our v of t, okay? And again, we need to find the particular solution, so we need to have v of 0 equals to v initial. So v of 0 of this is negative 1 over 2 cosine of 2 times 0 plus by c1, c1. Okay, we have negative 1 over 2 cosine of 0 plus by c1. Well, cosine of 0 is just 1, negative 1 over 2 plus c1. V of 0 is v initial. We have v initial plus 1 over 2 equals to c1. Well, our v initial here is 2. So we have 2 plus 1 over 2 equals to our c1. 2 times 2, 4, 5 over 2 is equals to our c1. Okay, great. So we have here v of t equals to negative 1 over 2 cosine of 2t plus by our constant 5 over 2. Now we need to find x of t. Well, x of t again is just the integral of v of t. So we have integral negative 1 over 2 cosine of 2t plus 5 over 2 dt. And again, integral of cosine is a sine. We have integral of negative 1 over 2. Oh, sorry. We're going to integrate this. Negative 1 over 2 times 1 over 2 sine of 2t plus by 5 over 2 t plus by our c2. Okay, this is our x of t. Well, again, we need to find x of 0. Well, x of 0 is just sine of 0 is just 0, so this cancels. So this becomes 0. And we have this becomes 0 also. So it's just our c2. X of 0 is just c2, so x initial equals our c2. Well, we have our position function x of t is equals to negative 1 over 4 sine of 2t plus by 5 over 2 t plus by c2. c2 is just x initial, so we have 8. So that's our particular solution. Next example, we have this a of t is equals to 2t squared minus t plus 2 over t plus 1. Okay, we have d squared x by dt squared equals to our a of t. Then our velocity is equal to the integral of this one, 2t squared minus t plus 2 over t plus 1 dt. Okay, as we can see here, we can use a long division. So we have t plus 1 2t squared minus t plus 2. Well, this becomes 2t. Let's do long division. 2t 2t times t, we have 2t squared plus by 2t. Okay, plus by is minus, this cancels out, we have minus 3t, this goes down, plus 2. Well, this becomes, well, we times this. I mean, we have minus 3, minus 3. And minus 3 times this one, we have minus 3t minus 3. Minus, we have, cancels out. 2 minus minus 3 is just 5. Okay? So we have, so this one will become plus 5 over t plus 1. Okay. So the integral becomes 2t minus 3 plus 5 over t plus 1 dt. Okay. We integrate this. This will becomes t squared minus 3t plus by 5 ln of t plus 1. Okay. Then this is our v of t. Again, we want v initial. I mean the particle solution. So we have v of 0 equals to v initial. So we have v of 0 is equals to 0 minus 0 plus 5 times ln natural log of 0 plus 1. Well, v of 0 is just 5 times ln of 1. ln of 1 is just 0, so v of 0. Wait, I forgot the plus c1. Plus c1. ln of 1 is just 0, so we have 0 plus c1. So c1 equals to v0. So c1 equals to our v initial. Nice. So that means we just substitute v initial equals to 4. So we have v of t. Let's write it here. V of t equals to t squared minus 3t plus 5 ln of t plus 1 plus by c1. c1 is just our v initial, so it's 4. Okay. Now we find the position function x of t. T squared minus 3t plus by 5 ln t plus 1 plus 4 dt. We integrate this. Okay, so you can see that x of t is equal, well, this is just t cubed over 3 minus 3 over 2t squared plus 5 times integral of ln t plus 1 plus by 4t, and then plus by constant of integration. Well, integral of ln t plus 1, okay, integral ln of t plus 1, t plus 1 dt. Well, we know that the integral of ln x dx is just x ln x minus x. So integral of this is just t plus 1 ln of t plus 1 minus t plus 1. So using that, we would have the position function x of t is equal to t cubed over 3 minus 3 over 2 t squared plus by 5 times t plus 1 ln of t plus 1 minus by t plus 1 plus by our 4t plus c2. Okay, let's figure out x of 0 is equals to x initial. So when time equals to 0, x of 0 is equals to, okay, let's look at this. So this of course becomes 0, this becomes 0, so 5 times t plus 1, see when it's 0, t is 0, so this whole becomes just 0, 0 times 1, this is 0, and minus 0 plus 1. Wait, we can make this as this term becomes 0, right? And which left us with t plus 1. Well, this becomes 0, and which left us with negative 5. Okay. So we have negative 5 plus 4, 4 times t, 4 times 0, 0. So negative 5 plus c2. So x of 0 is equals to negative 5 plus c2. So x is equals, so x initial equals to negative 5 plus c2. So c2 is just 5 plus x initial, which is 10. So it's 15. Okay, nice. So we have this, our particular solution. X of t is just t cubed over 3 minus 3 over 2 t squared plus 5. Let's substitute x equals to t plus 1. Let's do m then. M equals to t plus 1. That means 5 times m ln m minus by 5m plus by 4t plus c2. Okay, so if we rewrite this, x of t cubed over 3 minus 3 over 2 t squared plus 5 times t plus 1 ln of t plus 1 minus 5 t plus 1 plus by 4t plus c2, which is our 15. So this is our particular solution. Okay. To this basic differential equation. Okay, great.